So in continuing our solving equations section, we're going to revisit what we learned the first month of school, and that was working with fractional expressions, or otherwise known as rational expressions. So in looking at this problem, hopefully you're thinking, well, we've done operations with fractional expressions. We know how to add, subtract, multiply, and divide. So hopefully that will give us a good start in how to solve an equation that has a fractional expression in it. So one thing you could do is you could look just at the left side and say, let's come up with a common denominator and create a single fractional expression here. But then it gets a little tricky when you have a fractional expression equal to another fractional expression. I'm going to show you how to solve this using an overall LCD, least common denominator of the entire expression. So in this problem, all of our denominators are x minus 3, and x squared minus 9, and hopefully you see that this can factor into x minus 3 and x plus 3. So in looking for our least common denominator, we know, look, we've got a pair right here. We know it's going to involve an x minus 3, and then what else do we have left? An x plus 3 and an x. So that will be our LCD, and we're going to multiply both sides of the equations by that. So let's first write the equation down. If you've noticed, I just changed, the x squared minus 9 into the two factors. That'll help when we want to cancel things out. Now I'm going to multiply both the left and the right side by our LCD. Well, the left side, let's say we already have it right there. So on the right side, I'm going to do the same thing. Now, what can we simplify when we multiply the left side by that LCD? Well, when we take the first term, x's will cancel, and we'll be left with 3, x minus 3, x plus 3. And the second term, the x minus 3's will cancel, and we'll be left with minus 2, x plus 3, and x. And let me just move that over. Let's continue with the left side. I'm going to simplify, My x minus 3 and my x plus 3 will become x squared minus 9. And now if I multiply both by 3, I'll get 3x squared minus 27. And my x plus 3 and my x will give me x squared plus 3x. That's a plus sign. And if I multiply that by 2, I'll get minus 2x squared minus 6x. And if we combine like terms, we will get x squared minus 6x minus 27 for that whole left side right here. So now let's look at just the right side, We're going to distribute our LCD to our right side. Hopefully you see that the x minus 3 cancel, the x plus 3 and x plus 3 cancel, so we're only left with a negative 12x. And remember, that equal sign will come straight down. I'm now going to take my left-hand side and set it equal to my right-hand side. And I'm going to put it down here where we have more space, We're going to solve the equation like we normally would, distribute and combine all our like terms. Now we're going to solve it. And to solve it, we want to set everything equal to 0. So I'm going to add a 12x to both sides. I'll have x squared plus 6x minus 27 equals 0. Now I'm down to a basic quadratic that we're going to solve. We can factor into x plus 9 and x minus 3. That factoring always comes back, and this will give us an x equal to negative 9 and an x equal to 3 as our solutions. Now we're not finished. We still want to check our answers because we multiplied both sides by variables, and sometimes that'll give us extraneous solutions, just like we talked about when we were solving radical equations. Really what we're looking for, since we have rational expressions, we have problems in the denominators of our domain, when x is 0 or 3. So those are things that we are looking for our extraneous solutions. So let's start with that x equal to negative 9. I'm going to start with the left-hand side. It's a great abbreviation to use, and plug that straight in. My left-hand side is 3 over x minus 2 over x minus 3. I'm going to plug negative 9 in for x, and that will give me a negative 1/3 plus 1/6, because that's a plus 2/12. And if I simplify this further, I'll end up with a negative 1/6 for my left-hand side. Now let's look at the right-hand side. Right-hand side. I have negative 12 divided by, right, we're plugging that negative 9 into being squared, minus 9. That's going to equal negative 12 over 81 minus 9, which will equal negative 12 over 72. And surprise, surprise, that's a negative 1/6. These are equal, so negative 9 is valid and it works. But now let's check x equal to 3. And if I plug 3 now in, I'm going to get 3 over 3 minus 2 over 3 minus 3, and this will be equal to 1 minus 2 over 0, right? And that right there is a no-no. That means that x equal to 3 is not a solution, and our only solution is x equal to negative 9, and that should make sense because if you go back to our original problem, right, we can't have 3 in our denominator. So again, to solve these types of problems, we're going to look for that overall LCD and multiply it by both sides. So let's try another example. Here we have x squared divided by x plus 100 equals 50. Now hopefully you're saying, hey, this looks a little bit easier. It looks like something I've already done. And you're right. Think about when you had something like 3 over x equals 7/2, right? How did we solve this? You could cross multiply and get 7x equals 6, divide both sides by 7, and just get x equals 6/7. And we're going to do the same thing here. We could treat this as 50 over 1, and we're going to multiply that diagonal and set it equal to the other diagonal. So 50x plus 5,000. Now if we set this equal to 0, we can solve our quadratic. Now this you can try to factor, use quadratic formula, or even completing the square. Any of those will work. So I'm going to go ahead and factor this, and this will factor into x minus 100 and x plus 50 is set equal to 0, which will give us a solution of x equals 100 and x equals negative 50. But again, because we had a rational, right, expression here, we want to check our answers. Start by plugging it into the left-hand side, which means we're plugging it into x squared over x plus 100. This will give me 100 squared over 100 plus 100, which is, this will be 10,000 over 200. And if we simplify that, 100 over 2 is 50. Now let's check that against our right-hand side. And ooh, this one's nice and easy, right? Our right-hand side is just 50. And yes, 50 equals 50, so we know 100 is a valid answer. And now let's check our x equal to negative 50, right? Our left-hand side will be negative 50 all squared over negative 50 plus 100. This is going to equal 2,500 over 50, and if we simplify, we will get 250 over 5, which, yes, that is 50. And that 50, which is our left-hand side, will equal our right-hand side, which is 50 as well. So both answers are valid answers. And this problem has 2 solutions. But remember, when solving rational equations, right, whenever you have a variable, an x in the denominator, always check your solutions to make sure you don't have any extraneous ones.